Okay, a single slit illuminates. Our wavelength is 24 to the minus 9th. Okay, a screen. Ooh, look at this. 4.2 meters away has a central maximum where the first minimum on one side is separated from the second. First minimum, here's the minimum on one side, is separated from the second by a distance of 1.26 centimeters. Okay, how interesting. All right. So what we need to do is we need to figure out this angle. So this is going to be in terms of sine theta, lambda over d, right? Is going to be sine theta, right? Okay. So the first minimum from the second. Okay, yeah. 1.26. So let's find that angle. Theta is going to be, it really doesn't matter whether we use inverse sine or inverse tangent. I'm going to use, let's just use the inverse tangent. So tan minus 1 of 1.26 times 10 to the minus 2. That's this, right? Okay, over 4.2, right? So I'm just sort of pretending that this angle looks like this. It doesn't, but there's not a huge error for this, right? So let's imagine that's 90 degrees. This is 0.0126 meters, and then this side here is 4.20. Now, these sides are essentially the same length. I'm just using inverse tan. I could use inverse sine too. Let's play with this. Okay, so let's go inverse tan of 0.0126 divided by 4.2. And in terms of degrees, that's equal to 0.17188 degrees. That's a very small angle. All right, good enough. Okay, so now let's go, let's set up our number sentence here. Okay, so we're being told that it's here, this, right? So that's lambda over d is sine theta, right? So lambda over d is sine theta. So therefore, d is going to be lambda over sine theta. Okay, so this is 524 e minus 9 divided by the sine of 0.17188. I'm just going to use the number on my calculator. Okay, so let's see if we can get the right answer here. All right. 524 times 10 to the minus 9th divided by the sine of this number I just got. I'm getting d is equal to 1.7466 times 10 to the minus 4th, so that's about 1.75 times 10 to the minus 4th meters, which is, by the way, 0.175 millimeters, but this is correct, right? Now, for those of you that are, for some reason, still watching this video, right, what if I'd done the inverse sine of that number, right? Let's take this guy here. And instead of doing inverse tangent, I did the inverse sine. I get a number that's exactly the same all the way down to the 1, 2, 3, 4, 5, down to the 6th decimal place. Okay, I get the same answer if that's inverse sine, right? So these small angle things are a little bit loosey-goosey about, okay? Just a little loosey-goosey. I'm sorry about that. All right.